Hi everyone, my name is Oscar Fernandez. I'll be your professor for Math 215, Math Methods for the Physical Sciences. As you may have noticed, I'm not there. I'm at a conference currently in Spain where I was invited to give a talk. But don't worry, you're in good hands. Professor Chang, if you're in the morning section, will be conducting the first day's class, or Professor Tannenhauser, if you're in the 1110 section, will be conducting that class. I just wanted to take a quick second to, aside from introducing myself, go over a little bit of the items on the syllabus. So if you don't already have that in front of you, please take that out and we'll go over some of those things. All right, so let's talk a little bit about this syllabus that you all have in front of you. If you're in the morning section, then this is exactly your syllabus. This is the 8:30 to 9:40 class, but if you're in the afternoon section, the only thing that will change is this time right here and the section number. So there's a little bit of information about the course content. This section I'll probably talk more about on Friday when I get there. Feel free to read through it though. It's just a basic outline of what we're going to be covering. I'll be your professor as we talked about, and the first thing I really want to say that's important is office hours. So I really want to encourage you to come to office hours. You don't have to have an appointment, and you really even don't need to have a question. Completely fine if you come to office hours and you just want to talk about the class or maybe an interesting problem that you were working on that you wanted to discuss. So feel free to just send me an email. I do have office hours scheduled, and we'll talk about that in a second. But I just wanted to let you know that you can drop by without needing to have a question. So if we go back up to the top, the actual office hours that I have scheduled for now are Tuesday, Thursday, Friday, 12:30 to 1:30, and these are all in my office in 366. So the textbook for this class is Differential Equations and Their Applications, and the author is Martin Brown. So again, on Friday, I'll talk a little bit more about exactly how we're going to use this book. The majority of the time, we're going to be using it for the problems, and that's where your homework will come from mostly. But I will also make sure to tell you what the readings are that correspond to the topics that we cover in the class. In case you don't already have it, you can pick up the book at the bookstore. You'll need it for the problems for the homework that we'll talk about in a bit. Everything is going to be on Sakai, all the exam solutions, all the quiz solutions, all the homework assignments. So if you don't already have access to that, please email me and let me know. All right, so let's talk about the course design real quickly. The first thing you see under here is collaboration. And there are going to be many times during our classes that I'm going to ask you to try a problem by yourself first and then maybe consult with your neighbor to see if you two can find the solution. Or maybe just discuss the solution that you already found. There are a lot of learning benefits associated with this, and I've listed some of these here. But it's also a nice way to interact with your peers in the class, and it's also a good way for me to take the pulse of the class to see how everyone is understanding the topic. I have a couple of goals that I wanted to mention for the class. I really want to develop your critical thinking skills, because I know that many of you are science majors, so you may be majoring in chemistry or biology. So the math that we learn in this class, you'll have to apply and learn how to apply within your specific context, and that requires a great deal of critical thinking. So sort of adjacent to that, I'm going to make sure to emphasize both the theoretical and the practical aspects of the course. So there is some theory that we're going to need, and there is some application that will be beneficial, and then there's a lot of gray area in the middle, which is going to be a mix of theory and application that's going to lead us to the really important aspects of the course. So the next thing I want to mention is about attendance. So I do want to make sure that you come to class regularly. This represents a commitment not only to yourself, but also to your classmates' learning, since we'll be doing a lot of group work as we just discussed. Second important thing on here, you'll notice I skipped over the effort and support. I'll just say quickly that if you need any help, there's a lot of resources available to you, including myself, your peers in the math help room. But somewhat tied into that is academic integrity. So I do expect you to read and understand the college's honor code. So our final, for example, is going to be self-scheduled. So there's a lot of honor code involved there. But also throughout the semester, if you work with someone, Practically speaking, what this means is that I want you to name who your collaborators are. So that way I know that if I get two homework assignments that look the same, I know that maybe you and that person were working together because you've told me that on the first page of your assignment. So let's get into the grading of the course. Here's the basic breakdown. You'll notice that what's worth most is the final at 35%. You'll have two exams that are both 20% each, and your homework and quizzes will make up the rest. Homework makes up a little bit more since you work on that throughout the semester. In accordance with the college's grading policy, in case the final class average is not a B+, then I will curve up to a B+. If you are all conspicuously excellent, as the college defines an A grade, then if the average is higher than a B+, I certainly won't curve down. So rest assured that if you do great, then you will receive a great grade. One of the ways to do great, of course, is to do great on the exams. So there are two exams. First one is October 12th. The second one is November 20th. And your final exam is self-scheduled. So make sure to put these down on your calendar. I'll talk more about the exams once we get closer to them and review sessions and all of that. We are going to have quizzes. So there will be, I believe, 4 or 5 quizzes. We'll see that in the breakdown in a second. I'm not going to have any makeup quizzes. The exception is the SIC policy, which I'll talk about in a bit. But each quiz is going to be somewhat simple. You'll have 15 minutes to do one problem. There might be some subparts. The reason for that is I'd like to give you as much partial credit as possible. So if I just ask you the question without giving you subparts, maybe somebody will have completed the entire problem but done it incorrectly. So that's hard to grade. In terms of homework, so homework is going to be assigned every class, and it'll be due once a week. So the assignments will contain the exact due dates. It's due by 6 p.m. in my office, and this is the description of how the homework is going to be graded. You receive points based on how correct your work is, and also the fact that you did do work. So if you skip a problem, you get 0 points. But if you do a problem completely correct, you get 5 points. And then I add up the scores, and that's your score for the homework. You do have one late pass that you can use if you want to turn in one homework assignment late. And late means by the next class session. So after you use your late pass, I won't accept any late homework since it gets, with our weekly homework assignment due dates, a little hard to grade that. Let me talk a little bit about extra credit and what these discussion questions are. So on each of your homework assignments, you'll have a discussion question that asks you basically to think a little bit about the topic that we're going to be covering the day after. And you might want to do some Googling or some internet searching, but the idea is I want to get you in the frame of thought that we're going to be entering the following class when we discuss the topic at hand. So the discussion questions are going to be in your homework assignments, and if you submit an answer to them, you can just send me an email. Then you're going to get a certain amount of extra credit. So let's talk about that. So the extra credit that you get for your discussion section for submitting a response to a discussion section depends on when you submit it. So I really want you to submit this by 7 a.m. the day of the class. So if you send me an email with an answer to the discussion question by 7 a.m., then you'll get credit. It has to be a reasonable attempt. So most of these questions won't have a right or wrong answer. But I just want you to start thinking about the material that we're going to be covering. The benefit of doing this is that you're going to earn a certain amount of extra credit for this that'll be tacked on to your final grade. The best way to think about this is that if you answer all 31 questions, you'll get 2% extra credit. That may not seem like a lot, but as I mentioned here, it might be enough to switch your grade from, for example, a C+ to a B-, or maybe even a B+ to an A-. So another way that this extra credit can help you is that it can also offset low quiz scores. One thing you should also know is that in my experience, the students who completed these extra credits also ended up earning the highest grades in the course. So that's something to keep in mind. Here's the SIC policy that I was talking about before. If you become sick at some point and you have to miss some important assignments, all I ask is that you bring me some official documentation of your sickness, maybe a doctor's note, and we can talk about making up some of these missed assignments. Okay, so let's talk about the breakdown of topics, and I'll give you just a brief idea of what we're going to be covering and some important due dates. So the first part of the course is going to be focused on first and second order differential equations. So we're going to spend roughly, as you can see, about a month or so talking about these. In between there, we'll have our first quiz. That's on September 25th. That should give you a rough idea of what my exams are like. And that'll cover the first 6 lessons to get you some time to get those homeworks back and hopefully grade it. October 10th is when we'll review for the exam. This is right after fall break. So that gives you some time to study up on anything that you may need to study for the first month or so of the course. And then the actual first exam will be October 12th. After the first exam, we're going to transition a bit and talk about linear algebra, and later on we'll apply it to differential equations. So this linear algebra part will be about the first ending of October, maybe a little bit of the first week of November. So there'll be 2 quizzes interspersed. 2 quizzes interspersed in there that'll test you on some of that linear algebra. And the second exam happens on the 20th, right before we go off for a Thanksgiving break. We'll have a review the day before. The last little part of the class, it's not too much content. It's going to be an introduction to partial differential equations. So most of you being chemistry or physics majors, at some point will need to solve the Schrodinger equation for quantum mechanics. So this is the technique that we're going to use to do that, separation of variables. So we'll study that in the last week of class. And then our very last class we will review for the final. And that's a quick overview of the syllabus. All right, now that we've gone over the syllabus, let me mention a few important things. The first thing is that tomorrow's class is going to be online. I'm going to upload a video of the class to this same YouTube channel, and you can watch that anywhere you want. You don't have to come to class tomorrow, although you could if you wanted to. I'll be impressed if you're in the 8:30 section and you're coming to class to view the video, but you could view this video from home or from anywhere. I do ask, though, that you view the entirety of it, so it will be a 50 to 70 minute video to reflect the actual class that we would have had. The second thing is that I'll actually be back to Wellesley on Friday. So on Friday we'll have regular classes, so please mark that down on your calendars. I'm also going to have special office hours on Friday, so 12:30 to 2 is going to be the special office hour for Friday. And then on Monday I'm going to have special office hours from 1:30 to 3:30. So in the meantime, feel free to email me with any questions you have on the material, whether it's content or maybe any questions you have about the class, or maybe problems with Sakai that sometimes shows up. Other than that, I'm looking forward to meeting all of you on Friday, and I'll see you then.